Next, we're going to cover iSCSI. iSCSI is the Internet Small Computer System Interface Protocol. It runs over Ethernet networks and was originally seen as a less expensive alternative to fibre channel. It has higher packet overhead and has traditionally been seen as having lower reliability and performance than fibre channel does. However, you could argue that that is just a perception thing. As it runs over Ethernet, it can share the data network or have its own dedicated network infrastructure. Toll cards, which stands for TCP Offload Engine, are specialist adapters which can be used to offload the TCP IP processing from a server's CPU. They are also sometimes called iSCSI HBAs. HBA stands for Host Bus Adapter, and it is the SAN equivalent of a NIC, a network interface card for normal Ethernet data traffic. Let's have a look at our different network topology options. Here, server to storage and server to client is both using a shared Ethernet network. So our normal data and our storage traffic is both going through the same switches and also using the same network cards on our end hosts. If you tried to do this back in the day when we just had 1 gigabit Ethernet, then you could have problems. But now that we have 10 gigabit Ethernet and even faster speeds, this is more feasible. Another way we can deploy our network is using a dedicated storage network. In the example here, we've got server 1 in the middle. Let's say that that's a web server, and we've got a client up at the top, which is opening up a web page that is hosted on server 1. The client at the top sends its traffic to server 1 over our standard LAN data network up at the top. The server reaches its storage down at the bottom using a separate dedicated Ethernet network that is just used for storage. And the server here has got redundant network cards. It's got 2 standard Ethernet network interface cards pointing up to the network at the top facing the client. It's also got a pair of Ethernet ports going down facing the storage network as well. Those could be on standard Ethernet NICs, or it could be on those specialized toll cards that are used for our iSCSI traffic. Notice that we've got double the infrastructure here. If I go back to the previous slide, on the server, we've got 2 ports and we've got 2 cables that are connected to 2 switches. With the second option, on the server, we've now got 4 ports and 4 cables which are connected to 4 switches. So this second option is a more expensive way of doing it, but because we've now got this dedicated network for storage, that should give us more reliability. Another thing we can do is we can have a dedicated VLAN network for our storage, use a different VLAN for our normal data, and have them running through the same switch infrastructure. So in the picture here, I need to have connectivity between the client and the server. That is provided over my data VLAN. I also need to have connectivity from the server to its storage. That is provided over a separate storage VLAN. When we put it together, you can see that the data VLAN and the storage VLAN are both using the same switches, but we're separating them into separate VLANs for performance and security. On the server, we could have the data and the storage VLAN trunked down into the same physical port, or we could split them into 2 different physical ports on the server. We'd only have them both trunked into the same physical port if we had enough bandwidth there and we were confident that this was not going to give us any performance issues. On to the addressing now. So you saw in the earlier lesson that Fibre Channel uses worldwide names to identify initiators and targets. iSCSI uses IQN, which is iSCSI qualified names, or less commonly, it can use EUI, Extended Unique Identifier, for its addressing. The IQN can be up to 255 characters long and has the format that you see here. For example, the IQN could be IQN.1991-05.com.microsoft:/test host. Don't worry if you're looking at an IQN and it's got a really old date in there. The date is not really anything to do with the host. The IQN is derived from when that vendor applied for the IQN addresses. The IQN is assigned to the host as a whole, similar to the way that the WWNN is applied to the host as a whole in Fibre Channel. iSCSI runs over Ethernet, so individual ports are addressed by IP addresses rather than WWPNs that we use in Fibre Channel. iSCSI does not support Fibre Channel's floggy, ploggy, and PLRI login process, so an administrator must explicitly point the initiator at its target by specifying one of the IP addresses in the target portal group. It will then discover the target's IQN and the other ports in the TPG. Multipathing software on the initiator can then choose which path or paths to take. So multipathing in iSCSI, it works the same as multipathing in Fibre Channel. Although it runs over Ethernet, iSCSI is still a SAN protocol with multipathing intelligence on the initiator. LUN masking is also configured in the same way as in Fibre Channel, this time using the IQN rather than the WWPN on the storage system to identify the client. Zoning is not supported in iSCSI on our switches. Password-based authentication is typically configured on the initiator and target to guard against spoofing attacks, and end-to-end IPsec encryption can also be enabled if you need to enhance security further. I'm back in the lab and we're going to have a look at how iSCSI works from the client point of view. I'm on a Windows host here and I'm going to open up the iSCSI initiator. It'll prompt me to start the iSCSI service, so I'll click yes to that. And then the iSCSI initiator window will pop up. I've already configured a LUN for this host on my storage system, so to connect to that I click on the Discovery tab in here and then I click on Discover Portal. I enter one of the IP addresses that has been configured for iSCSI on my storage system. That's 172.23.3.33 for this example, and I click on OK. And now if I click on the Targets tab, I can see that it's discovered the IQN of my storage system. Next, I click on Connect and enable multipath and click on OK. And I can see that I'm connected, so I'm done in the iSCSI initiator. I'm going to click OK to come out of here. So I'm connected to the storage, but if I open up Windows Explorer, you see that I've still only just got my C drive that I had already and my DVD drive. I can't see my SAN storage in here. The reason is with iSCSI, it's a SAN protocol, so my client gets block level access to the LUN. I need to make it ready for use. To do that, I need to go to Disk Management. That's now called File and Storage Services in newer versions of Windows Server. I click on Disks and I can see the LUN that I've connected to over iSCSI. To use it, I need to right click and bring online. It gives me a warning message to check that it's not already in use by another server. It's not, so I can click yes to that. Then I'll see a message to create a volume, start the new volume wizard. I'll click on that link. And this will open the new volume wizard, which will help me format my LUN and assign a drive letter. To continue, I click on Next. I'm provisioning it for this host, which is WinA, and it's disk 1, which is my iSCSI LUN. I click on Next. It tells me the disk will be brought online and initialized. I click OK to that. The size of the volume will by default use the maximum size. I click Next again. The local drive in the server, which is Windows installed, is the C drive. I have a disk drive as drive E. My next available drive letter is E, so I'll accept that and click on Next. I'm on a Windows server, so the default file system will be the NT file system. I'll accept the default for the allocation unit size, the volume label. I'll call this iSCSI LUN. And then click on Next. I'll see a confirmation page that summarizes my selections, and I click on Create. Once it's done, I can close this window, and I can click on the volumes page up in the top left, and I'll see my iSCSI LUN showing up there as the E drive. If I open up Windows Explorer, I see my E drive in here now, and I can now use my storage. It acts just like it would if I had a local drive in my server here, and the server has got block level access to that disk.